Hello and welcome. Let's look at lesson 6.2 today. 6.2 is a lesson about approximating area under the curve. And I know in 6.1 we were looking at that accumulation function and we were able to use geometric shapes to help us find the area under the curve. Well, today our geometric shape is going to be pretty much entirely a rectangle. And we call this using Riemann sums. And we can have left bound, right bound, or midpoint calculations for the height of our rectangles. We can also have equal or unequal subintervals. So all of this will make sense soon as we get into this. What is a Riemann sum? If we have nice consistent subintervals, meaning if this is my function, I'm going to draw rectangles underneath it to help calculate out the area. This is what a Riemann sum does. In a consistent one, maybe the width is always, 2 units wide, 2 units wide, 2 units wide. So that's what this means by consistent subintervals. We take this big interval from A to B, let's say from A out to B, and we subdivide it evenly so we get these nice consistent subintervals. To calculate a rectangle, well, we know it's nothing more than width times height, so at least we've got an easy geometric figure to work with. When calculating the width of our subintervals, which we will call delta x, because it's a change of x, like how far apart is x, then that can be calculated by doing the two endpoints, a minus b over n, where we have on the interval A to B. It probably actually would be, we'll put a solid, so we're including our endpoints. Now the height's going to be determined by our function, right? If I put in an x, I get out a y value, or a height. A car is traveling so that the speed is never decreasing during a 12-second interval. The speed at various moments is listed in the table. So it says, estimate the distance traveled by the car during the 12 seconds by finding the areas of 4 rectangles drawn at the heights using the left endpoint. So by using the left endpoint, I'm taking it into my function and I'm determining the x value by looking at the value on the left-hand side of my rectangle, because there's obviously a left side and a right side to a rectangle. So we're going to use this left height to determine how tall to make our rectangle. So our subintervals, well, let's see, I saw it somewhere, 4 rectangles. So my n value is 4. I want to make 4. And we had 12-second interval. We were on this interval from 0 to 12. And so in order to calculate out delta x, I'm going to do that b minus a divided by n, which in this case is going to be 12 minus 0 over 4. And that's going to give me the width, oops, n was 4. Guess that was going there. That's going to give me a width of 3. Now let's go over to our diagram and draw in these units of our rectangles that are 3 units wide. So I'd have 3, 6, 9, and 12. Now the height of the rectangle is determined by the left-hand side. So I chose to read the height of 30. The next rectangle, I'm going to change ink colors, will be determined by the left-hand height. Sorry, my board is just not aligned real great. I'll do my best to accommodate and adjust. There's my next one. Let's draw in the one at a height of 6. I see there's 6 and 45. There we go. And then back to 9, goes up to a height of 54. And that is it. We needed 4 rectangles, didn't we? Have 1, 2, 3. We have 4 rectangles. They all have a delta x of a width of 3, you'll notice. And now I just need to calculate out, well, what would the area be of that one? This one would be a 3 by 30. The next one would be a 3 with a 3. Looks like 37 is its height, and so on, okay? So there's a formula or an equation that we need to show for the AP. This is my delta x multiplied by the height. If I'm left-hand bound, we said we were going to estimate the height by going into our function f at 0. Then I have a width of 3 times f of 3 was my next point that I would evaluate at. 6 would be the next height I need, and f of 9 my final height. We can see by our table that f of 0 was 30. I'm just reading my ordered pairs here. 3, 37, so f of 3 gives me 37. F of 6, you get the idea, is 45. F of 9 is 54. So I converted delta x times f of x into an equation. And now let's get the sum of these products. You do notice on this one, there is a 3 in common. If you want to GCF that 3 and go 30 plus 37 plus 45 plus 54, you could also calculate it this way, couldn't you? And that would be a 3, oh, I didn't write down my number. I'm just going to give you that this ends up being 498. I multiplied seconds times feet per second. How did I get that? Well, my independent axis was seconds, and then this would have been the rate of change, feet per second, as shown in the table. So I took feet times feet per second, and we end up with 498 feet as our distance traveled. Left-hand based. For the AP, you must show this line level. They need to see, AP requirement, they need to see the equation that shows the sum of the products. And then, however you want to calculate out to get to your final answer. All right, the next one is an example of a right Riemann sum. We're still using the car traveling 12 seconds for rectangular areas, but in this case now, we're going to use the right-hand side. Now, the first time I didn't use the table near as much. I relied on my graph because it was easy. This time I'll also reference the table a little bit more. So let's go in and mark our 3, our 6, because these are our major divisions. They tell us, where our rectangle is going to lie. Now I'm going to draw in the representative rectangle. Let me change this color a little bit. Let's put a yellow on there. That should, oh, come on, move with me. That should work. Okay, where's the save? Now, I'm going to build a rectangle, and I'm going to travel up until I reach that right-hand height, which says it's 37. In this case, I will never use that left-handed side of 30. I'm going to first make this a height of 37. Then my next rectangle, I'll go across to 6, and now I'm traveling up the right-hand side until I reach 45. Then the next rectangle, I'm over at 9. I went to the right-hand side, travel up till I intersect my curve, which is the height of 54. And finally, my last one, I'm going to draw it up until I reach 65. So you can see the 4 heights that we're using. If you wanted to, hopefully you drew in your rectangles while we were doing it as well. Those are our 4 rectangles. Each have a width of 3, don't they? So we're going to take 3 times f evaluated. Here's our first subinterval. It's going to be evaluated at 3. We want to use the right-hand side. Then the next interval, we'll evaluate at 6. The next subinterval will evaluate at 9, and the last subinterval will evaluate at 12. Now let's bring in those heights: a 37, a 45, 54, 65. Either I was looking at the table to grab those heights. You also could have been looking at our example of the rectangles. Now to get that area, once again, I see a nice consistent subinterval. I'm going to pull the 3 and show that it's 3 times 37 plus 45 plus 54 plus 65, and get a final answer of 603. Remember, this was seconds and this was feet per second. So if I have seconds multiplied by feet per second, we obviously end up with an answer in feet. 603 feet difference, distance traveled. Since this is an increasing function, does it make sense that the right hand Riemann sum is greater than the left Riemann sum? For sure, right? If my function is increasing, then the right hand side is always going to be a larger value than my rectangle determined from a left Riemann sum. Finally, we get to the last one, which is asking for a midpoint Riemann sum. Now, midpoints are done a little bit differently. It's neither one of these heights, because I need to figure out what's in the middle. If I were given an equation, I could go in and ask for, what was the height when I was at 1.5. Instead, this one's done a nice adjustment, and it says we're only using 2 rectangles. So our n value is 2. We still have our b minus a over n, which is a 12 minus 0 divided by 2, giving us a width of 6. So these are going to be longer, broader. I'll have till 6, and then I'll also have the next subdivision marking off at 12. So I want to take the area 3 of something. This has to be the midpoint of this subinterval. And then I need a midpoint of this subinterval. And we can see how 3 and 9 sit in the middle of 0 to 6 and 6 to 9 respectively. So I'm going to take 3 times f of 3 and 3 times f of 9 to determine the heights of my midpoint Riemann sum. For the 3, it has a height of 37. And when I evaluate at 9, it has a height of 54. And let's draw in. Our first rectangle has a height of 37. And that second rectangle has a height of 54. So maybe you want to hit pause, draw those in. You can see that we have a delta x equal to 6 here and a delta x equal to 6 there, allowing us to get a middle value. All right, final answer on this one ended up being 546 feet. Is it surprising? Left hand bound, we had 498. Right hand bound, we had 603. And somewhere based on midpoint, we ended up with 546. Does not surprise me to see that the midpoint value of that area landed between the left and the right. Yep. All right, example 2. Given the function of y equals x squared plus 1, this time they gave us the formula, didn't they? Maybe take your highlighter and note that to yourself that we do have a formula. Estimate the area bounded by the graph of the curve and the x-axis on 0 to 2. And I look at my graph, I look at my chart, and I've got 0, half, 1, 1.5, 2. Part A, do a left Riemann sum using 4 subintervals. So n is 4, isn't it? N is 4. Delta x is determined by b minus a divided by n. So it's the full width of our interval. which is 2, or I could do 2.0 minus 0, divide by 4, and it's telling us, oops, I need to get a 0 in front of there, half unit is our delta x. So I'm going to have a half unit, a half unit, a half unit, and a half unit. Once again, we're still staying nice and consistent with our delta x. Pretty soon we're going to change that up. Okay. What I don't have quite as easily this time, here's that half, 1, 1.5, 2. What I don't have is what the height is. So this first one was a left Riemann sum. If I drew that in, I would be taking, oops, let me get back to my rectangle. I would want to determine the height based on the left side. And in this case, it looks like I would have a height of 1. And that's because I'm going to evaluate it at 0. So I put 0 in, and I get out 0 plus 1. I get out 1, don't I? So that becomes a value of 1. F of 0, I would have 1/2 times 1. Now we need to go evaluate at a half. I put a half in, I'm going to have 1/4 plus 1. So I would end up with 5/4 for my height. So this was evaluated at 1/2, and I ended up with 5/4 as my height. If you want to draw that in, remember we're left-hand based, so I'm looking for these left edges. Left edge, left edge. The next rectangle is going to be determined by putting in 1 and the height at 1. So I would have 1 squared is 1 plus 1. We get out 2. So this is going to be an F evaluated at 1. That means the height came out to be 2. Finally, this last one, we're evaluating at 1.5, which is like 3/2. I need to square 3/2 and add 1. That's 9/4 plus 4/4. Looks like we get 13/4. And that would be this rectangle, 13/4. Or 3 1/4. Oops, I could go up a little higher, but I can't. I don't think. Let me see if I can get a hold of that. Yeah, it's a little bit harder to adjust that, but there we go. We're up there. So 13/4. I don't really need to go on to that last one because I'm left-hand based. I already have my 4 heights. So I'm just going to leave that. We will need it for right-hand side. When I put all this together, and yes, you do need to be able to do that by hand, I would probably pull out the 1/2. I'd have 1, looks like everything's in fourths, so I'm going to say 4/4 plus 5/4 plus 8/4 plus 13/4 gets me 9, 17. Looks like we have 1/2 times 30/4 perhaps. And that's going to give me 15 halves, so 15/4, which is about 7.5. Yeah, you should be able to do that by hand as well. All right, the next one, right Riemann sum. Now, you know, this begins my first, second, third, and fourth subinterval. The heights are going to be determined by using the right-hand side. Let's just go put a dot at those heights there, at 1, at 1.5, and then finally at 2. We'll have our rectangles be that height, that height, that height, and this height. So you get your 4 in there. Now our subintervals, we're still sticking with 4. We know we've got a 2 minus 0 divided by 4, so 1/2 is our delta x, and we've got that marked off. And we won't be using the very left-hand height, because this is going to be right-hand based, isn't it? And that first right-hand height is 5/4. So I was evaluating F at 1/2, and I ended up with 1 times 5/4. The next one I'm evaluating at 1. Sometimes this helps too, to draw in those subintervals. And we did not use the left side, so I'm working from evaluation at 1/2. Now I'm evaluating at 1, comes out with a 2 for its height. The next one I'm evaluating at 1.5, and at 1.5 it checks out to be a height of 13/4. And lastly, this one we're evaluating at the 2, and it comes out to be a height of 5. And once again, I would pull out that common 1/2. I'm going to take everything to fourths again, just so I have that common denominator, which is required when adding fractions. So I could put all that together. What do we get? 13, 26, 46/4. So I have 1/2 times 46/4, which is like 1/2 of 23 halves, reducing that down, which gives me 23/4. 4 goes into 20 5 times with 3 remainder, getting 5.75. All right, then we come in with midpoint, and I'm going to make us do the midpoint with 4 subintervals this time, just to show you how, it's a little bit more complicated when we've got to go in between, because we're still working with 1/2 delta x values. So these are our main subintervals. Problem is, I want to evaluate right here, right here, right here, right here on the midpoints. So I want to evaluate when x is 1/4, 3/4, 5/4, which fits between there, and 7/4. I would put these into, I keep touching this with my rectangle finger, and okay, I would put these into my y equals x squared plus 1. So I'd have y of 1/4 equals 1/4 squared plus 1. That's 1/16 plus 16/16, getting us 17/16. Just for the video, I made this a little bit faster and have done those calculations for you. But you see how to do it, right? You would have to evaluate each. The next one would be evaluating y at 3/4, and then y at 5/4, and so forth. I think you understand that. All right, we got the values. We're working on midpoints. So put a dot in the middle of these half-unit subintervals. And that's the height then that our rectangle is going to climb. There and there, height of 25/16. Height, oops, moving that. Let's try this again. Height of 41/16. And then it just doesn't like when I touch that again. All right, and then finally our last rectangle determined by the midpoint height of 65/16. 1, 2, 3, 4. This was evaluated at 1/4, 3/4, 5/4, and 7/4, giving us 1/2 of a height of 17/16 plus 25/16 plus 41/16 plus 65/16. And I'm going to make it easy on us. I've got the number. It came out to be 4.625. Check back between your left, your right, and your mid. Mid ended up being in the middle somewhere, didn't it? Or in between. I wouldn't say necessarily in the middle. Lastly, how much time are we at? 25. This last one we'll shoot through here, and then we're done. More typical for AP problems is the use of inconsistent or non-consistent inconsistent intervals where they're going to vary. So inconsistent subintervals. And they tend to give you a chart, which is kind of nice because I like when I have the numbers presented. Water's flowing into a tank over a 14-hour period. I can see that 14-hour period, 0 to 14. The rate at which the water is flowing into the tank at various times is measured, and the results are given in the table below. R of t is measured in gallons per hour. So R of t is a rate. Even though it doesn't say R prime, it is a derivative, isn't it? It is a derivative function, just named R of t. The tank contains 150 gallons at time 0. That'll become important, I'm sure. All right, estimate the number of gallons in the water of the tank at the end of 14 hours by using the values in the table and, once again, 4 subintervals. So I know my n value is 4, but since it's not consistent, I'm not going to go b minus a divided by 4 and come up with, what, 7/2, 3.5 units. No, instead, I need to use the values presented in the chart because they did not give me any f of x or r of t function that I could actually plug in, values of. So I have a delta x of 5. Please write these above like I am. Delta x of 3. A delta x of 4. See what I mean, how it changes? All I'm doing is 12 minus 8. Here I'm going to go 14 minus 12 and come up with this has a width of 2. Next thing, let me get some room, and I'm going to show my sum, or my area will be, let's say it's area. Okay, so I need to take delta x times r of t, right? That's really what I'm doing, width times height. And then I'm going to add the different ones. So I'm going to take a delta x of 5, and I am left-hand based. So I won't be using the far right one. The first delta x will match up with 8, height of 8. The next delta x, which is 3, will match up with the height of 8.8. The next delta x, 4, will match up with the left height of 9.3. And finally, the last delta x of 2 will match up with the left-hand side of that rectangle, 9.2. Approximately how many gallons were added after 14 hours? Well, if I add this up, which I have done for you, I came in with 122 hours times gallons per hour, which is going to be gallons. So I had 122 gallons. Now, had the question asked how many gallons are in the tank after 14 hours, I need to consider that there already was 150 gallons in the initial tank at time 0, and we have now put in an extra 122 gallons, giving us a grand total of 272. That is a left-hand calculation. Let's go do a right hand. We still have our delta x's that we need to, calculate out. Delta x was 5, delta x is 3, delta x is 4, delta x is 2. This one is right-hand based, so I will not be using the very first number. Imagine that I drew a rectangle from the span 0 to 5. Remember how we had these plotted out? Here's 0, here's 5. On the left side, I had a dot at 8. On the right side, it says I have a dot at 8, 8. Well, my rectangle is based on the right-hand side. So I'm using 8, 8, not using 8. All right, so I'm going to say my area. I just got to thinking, what we could show, the integral like we talked about yesterday with the accumulation of r of t dt is about, because this is a definite approximation, is about width 5, height 8, 8. We've used that one. Plus width 3 times the next right side, 9.3. use that one, plus 4 times 9.2 plus 2 times 9.0. And if we add all that up, I get 126.7. Definitely less than what we had last time. How many gallons were added over those 14 hours? Notice how our integral says 0 to 14 was 127. We started with 150 gallons initially at time 0, add in the 126.7 gallons, and now the tank contains, at the end of 14 hours, the tank contains 276.7 gallons total. Midpoint. Midpoint, when you're given a chart, has to have a value that sits between. So I wouldn't be able to go there because I have no clue what that would be. And I don't want to do an estimation and call it 8.4. You will never have to do that. So instead, the AP will adjust and say, use 2 subintervals. So there's my 2 subintervals. What you'll notice is that there is clearly a value then that sits, in the middle of those 2 subintervals, if you imagine, that. So I have a delta x here of 8, correct? And then 14 minus 8, I have a delta x of 6 on that side. So my integral still goes 0 to 14 r of t dt. And it is about, with 8, height. What are we choosing for height? The midpoint one. Notice 5 isn't necessarily in the middle of that interval or exact middle, but it's the closest thing I have to work with that sits between 0 and 8, so that's what I use. And then 6, 12 is where we're estimating this at, and we come up with a 9.2 height. And that gets us a value of 125.6 gallons. So after 14 hours, using a midpoint calculation, I get 125.6. How many are in the tank? Well, we take that 150, wasn't it? 150 plus the 125.6 to get us 275.6 gallons. Midpoint is often more accurate than left and right. That's going to bring you to your homework, and hopefully it follows along just like we have done in our practice problems. So good luck.